Hello my viewers, welcome once again to my channel Israeli Math Concept. In this tutorial, I'm going to teach you how to solve a given pair of linear equation which involves fraction. I want to read out the question first of all. The question says, solve the equation 2 over y plus 3 over x is equal to 12 and 5 over y minus 3 over x which is equal to 9. So many times students do find it difficult to solve a problem of linear equation that involves fraction. And in the course of this video, I'm going to teach you the simplest way to solve a given problem of this kind. Let's proceed with the solution. Looking at 2 over y, it can still be put as 2 in bracket 1 over y. Because if we multiply out by saying 2 multiply 1 over y, it will still take us back to 2 over y. The same thing is applicable to 3 over x. It can still be put as 3 in bracket 1 all over x, and that is equal to 12. Then looking at the second equation, we can still do the same thing we did for this in this same equation, such that we still have 5 in bracket 1 over y, then minus 3 in bracket 1 over x, and that is equal to 9. Because 5 multiplying 1 over y will still take us back to 5 over y, and in the same vein, negative 3 multiplying 1 over x will still take us back to 3 over x, and that is equal to 9. Alright, looking at this, let's look for two letters to represent it with this 1 over y, or two letters that can replace the terms 1 over y and 1 over x respectively. Let's take q to be equal to 1 over y, and also let's take p to replace 1 over x, such that we now have 2 in brackets. Whenever we see 1 over y, we replace it with q, because q is replacing 1 over y now. So 2 in bracket 1 over y now is our q, then plus 3 in bracket 1 over x is now our p, and that is equal to 12. The same thing is applicable here. We have 5 in bracket 1 over y is now our q, minus 3 in bracket 1 over x is now our p, and that is equal to 9. Such that when we open up the brackets, 2 multiply q will give us 2q, plus 3 multiply p will give us 3p, and that is equal to 12. Let's call this equation 1. In the same vein, 5 multiply q will give us 5q, minus 3 multiplying p will give us negative 3p, and that is equal to 9. Let's also consider this as equation 2. We can then solve equation 1 and 2 simultaneously using either substitution method or elimination method. But in the course of this video, I'm going to use elimination method to solve these two pair of linear equations simultaneously. Alright, looking at 3p, which is positive, and negative 3p, they have the same term, 3p and 3p, but their signs vary, such that we look for a sign to attach in this given place, such that we can be able to eliminate 3p and negative 3p. Let's take positive. Then 2q plus 5q will give us 7q. Then plus 3p plus minus 3p will be 0, which is already trivialized. What do I mean by that? 3p, let's write it out first of all. 3p, then plus minus 3p, plus minus 3p, which I say is 0. How do we get the 0? This implies that we have 3p, then plus multiplying minus will be minus, then 3p, such that 3p minus 3p will be 0. So automatically, plus 3p plus minus 3p will be 0. And we don't need the 0. Hence, we have that it is equal to 12 plus 9 will give us 21. Then when we divide both sides of the equation by the coefficient of q, which is 7, we have that 7q all over 7 is equal to 21 over 7, such that 7 will cancel out 7 and we are left with q, and our q obviously is equal to 21 divided by 7 will give us 3. Then let's substitute for the value of q in this equation 2. Remember, this is equation to 5q minus 3p equal to 9. So wherever we see q in this equation 2, we replace it for 3, such that we now have 5 in bracket. What is now our q in this equation 2? Q is now 3, then minus 3p, and that is equal to 9. 5 multiplied 3 will give us 15, then minus 3p equal to 9. Then we then have negative 3p is equal to, here we have 9, positive 15 crossing to the right hand side of the equation, it will change its sign to negative 15, such that we have that negative 3p is equal to 9 minus 15 will give us negative 6. Then when we divide both sides of the equation by the coefficient of p, which is negative 3, we then have the negative 3, we cancel out negative 3, and we are left with p, and that is equal to negative, we cancel out negative, and we are left with 6 divided by 3, which is 2. But actually, the p and the q respectively are not the real values we are looking for. The values we are looking for is the original values of x and y, which we are asked to find, or we are trying to find. So how do we find it? We then recall that because that we stated clearly that q is equal to 1 over y, we recall that q is equal to 1 over y, and we also recall that p is the same thing as 1 over x, is the same thing as 1 over x, such that wherever we see this q now, we can now replace it with 3. Then we then say when q is equal to 1 over y, remember that q is now 3, then we replace it or substitute it with 3, so that we have q as 3 equal to 1 over y. Then when we cross multiply, 3 multiplying y will give us 3y, and that is equal to, remember 3 is same thing as 3 over 1, so that 1 multiplying 1 will give us 1. Then dividing both sides of the equation by the coefficient of y, which is 3, we have 1 over 3 and 1 over 3 here, such that 3 will now cancel out 3. And this implies that y, which is remaining at the left hand side of the equation, is equal to 1 over 3. This is the real value for our y. Alright, let's also find the value of x. We then say when our p is equal to 1 over x, remember that our p is now 2. Then we substitute p for 2 in this given equation. So wherever we see p, we replace it with 2, so that we have that 2 is equal to 1 over x. Remember that 2 is the same thing as 2 over 1, because any number divided by 1 will still give you that same number. Then x multiplying 2 will give us 2x, and 2x is equal to 1 multiplied by 1 will give us 1. Then we now divide both sides of the equation by the coefficient of x, which is 2. Then 2 we cancel out 2, and we are left with x, and x is equal to 1 over 2. So the value of our x is now 1 over 2, and the value of our y is 1 over 3, which is the real answer we are looking for. Then we can put it in coordinate form as, remember, coordinate form simply means the x, y axis. The x, y axis. Such that this implies that our x is now 1 over 2 in comma, and our y is now 1 over 3. So this is the answer for this pair of linear equation which we solve simultaneously. If you found this video so worthwhile, try to reshare this video, and as well subscribe to my YouTube channel, Israeli Maths Concept, so that whenever I drop a new maths content, you will be notified. Thank you and see you next time. Goodbye.